All right, in our last videos, we were looking at using substitution to solve systems of equations. And in this video, we are going to introduce a new method to solving systems of equations called elimination. We're going to look at one of the same examples that we did last time with this dinner example where people are going out to eat and we know how many people are in total and we know how much the final bill was and the price for each kind of type of person to eat, adults versus kids. And we set up a system of equations here with we know if x is the number of adults, y is the number of children, 18 people total. When I add up the adults and children, that gives me 18. And when I add up the costs of each of their meals, each adult is $13.50, so the total cost was 13.5 times however many adults, plus $1 per kid, so just add on the number of kids, and that would give you your total meal. And so we looked at this graphically, we solved this, just plugged them both in and found what makes both equations true. The only thing that makes both true is if there's 12 adults and 6 kids. Then we looked at algebraically the substitution method, saying I can put in, if I get y by itself or x by itself, I can put in the expression on the other side that's equivalent to y in for y in the second equation. And we solved that way. We're going to look at another way to solve this. We're going to take the same exact system up here, where the two things are true, and we're going to look at just a different, another way to solve this called the elimination method. So it's also an algebraic method, and sometimes it's easier, sometimes it's harder, sometimes it's about the same, You can kind of decide which way you're going to go, but we are going to take a look at both of these equations here. So one thing I can do, whenever I have any equation, let's look at the second one here, is I know that I can subtract anything I want to, or add anything I want to, or multiply it, as I can basically do any mathematical operation to this thing as long as I do it to both sides. I could double the left side, double the right side, it would stay equal. I could add 15 to the left side and add 15 to the right side. That equation would stay equal. What I'm going to do is I'm going to take this equation and I'm going to subtract 18 from both sides here, I got this little divider line there, If I subtract 18 from the right side and subtract 18 from the left side, I know that this equation is going to stay true. It doesn't seem very helpful though, I'm subtracting 18 here, that's going to be 150, when I do that. And if I subtract 18 over here, I'm just going to get this kind of complicated thing. But let's think about, I'm basically using another version of substitution here. I know that 18 is equal to x plus y. So what I can do is say, I could subtract 18 maybe from the right side, but what would happen if I would subtract x plus y from the left side of the equation, X plus y and 18 are the same thing. I'm just going to substitute in this expression, x plus y, in for the 18 here. And so I'll subtract 18 from the right side and x plus y from the left side, and that will end up simplifying things a little bit more, Because if I subtract x from 13.5x, I get 12.5x. But if I subtract this y from that y, if I have one y and I take it away, I subtract it, I'm left with 0, There's nothing there. And so I just have 12.5x equals 150. What we often refer to this as doing, instead of doing all of that process, I just say, hey, I can really subtract one whole equation, from the other. I can just take away this top equation here, x plus y equals 18. Let's just subtract that whole thing from this. That's effectively what we're doing, I'm subtracting 18 from the right-hand side, subtracting the variables from the variables on the left-hand side, and that ends up canceling my y values here. So I just end up with 12.5x equals 150 by just subtracting this top equation from the bottom one, And now I can solve, I have 12.5 times x equals 150, so let's divide both sides by 12.5, because that's going to cancel the 12.5s here, and I have x equals 150 divided by 12.5 is 12. Right? The same answer that I got up here, and really I got the same result, right? The 12.5x equals 150. I ended up in the same location, just got it a slightly different way, right? And again, I'd have to go back, plug it back in, right? 12 plus y equals 18. Subtract 12 from both sides, and I get y equals 6. So again, 12 adults, 6 kids. We call this the elimination method because when I subtracted this one equation from the other one, my y's went away, right? I canceled them out. I subtracted one from the other to eliminate one of the variables, and just I'm left with the other variable. I'm only left with the x. It's effectively the same thing that we're doing when we do a substitution, right? We kind of get rid of one of the variables. We replaced the y with some expression that doesn't have y in it. So you could almost argue that's a different way to eliminate the variable. This one's just really direct, right? I subtract y from y, it went away, and I'm left with this. Right? So that's the basic introduction to this elimination method, and in the next video we'll look at a slightly more complicated example.